This is the typewriter printer, or type printer, or whatever that I've created. Before taking a closer look at it, let me briefly tell you how this project got started. 7 years ago, I converted this beautiful old typewriter into a functioning keyboard, and I created a YouTube video about that, which received quite a lot of views. Then, sometime later, I inherited this old electromechanical typewriter. On this typewriter, the keys have a very short travel distance and feel almost like a PC keyboard. Of course, they don't do much until it's turned on. Compare this to my fully mechanical typewriter, where you need to push each key quite a long distance and with considerable force. I immediately had the idea that this typewriter could be turned into a printer. Now, as those keys almost feel like a keyboard, I thought that they were individual switches, and that all I needed to do to turn this into a printer was to selectively shorten these switches. I was quite surprised when I opened the typewriter and found that the only electrical component in there is a motor. Actually, there's even a full circuit diagram on the inside. Now, the way that this works is that the motor continuously spins the shaft. Each key is connected to a lever, and by pressing a key, you push this lever into the shaft. And there, through some clever mechanism that I don't really understand, the stamp for one key is catapulted onto the paper. Now, the only way to turn this into a printer is to actually physically press each key. So, this is how the idea for this project was born. The typewriter has about 50 individual keys. My plan was to press each key with a solenoid. There are just two problems though. First, the size of a key puts a hard limit on the size of the solenoid. And second, if you want to buy 50 of something, things get expensive. So I decided to directly import solenoids from China. I found these ones on Alibaba, which are just large enough to fit one per key. And they were just selling for $2 a piece, which is crazy cheap compared to what I would have to pay locally. So I ordered 50 of them. To show you more how this works, let's take it apart, which is actually a huge pain in the ass. Each solenoid is connected through a barrel connector. I chose barrel connectors because they're quite cheap and they're rated for high currents. The solenoids for a row of keys are grouped into a module. A module consists of a 3D printed frame and a thin aluminium profile on the back side. This profile actually serves two purposes. First, it provides additional stiffness to the frame. And second, it acts as a heatsink, as these solenoids can get quite warm. Let's have a brief look at the electronics. I designed all the electronics in KiCad. The mind of the whole machine is a Raspberry Pi, to which we connect through the Pi's GPIO pins. We are actually backpowering the Pi through the I/O pins, which is not the recommended way of powering it, but it seems to work well enough. Then we have the barrel connectors, which are arranged into a matrix. The layout of those connectors here matches the keyboard layout, which I did so that I have some idea of what connector does what. Actually, each row is split into two rows, which I labeled A and B. This is done in order to reduce the number of transistors that we need for driving this. At each barrel connector there are two diodes. One diode is mounted in series. This one makes sure that current only flows in the intended direction, which is from column to row. Then there's also a flyback diode parallel to each connector. This diode is needed because a solenoid is an inductive load and hence resists to changes in current. The flyback diode allows the solenoid to maintain this current until its energy has depleted. Without that, we would get a high voltage spike when we try to cut power to the solenoid, which would kill the driving circuit. Let's have a look at the row drivers. There are actually two transistors for each row. First, an N-channel MOSFET acts as a current sink. Because the solenoids are powered by 12 volts, we can't switch these transistors from the 3.3 volt I/O pins, as the threshold voltage can be as high as the source voltage minus 2 volts, which would be 10 volts in our case. This is why we need a second transistor, for which I chose a BJT transistor, but we could have just as well used a small MOSFET. With the second transistor we are actually inverting the circuit, but we can compensate that in software. The column drivers look quite similar. The only difference here is that we use a P-channel transistor instead of an N-channel transistor, because we need to source current instead of sinking it. On the software side, the Pi runs a CUPS print server. It has a printer driver installed that will print any job to a PDF file. A background script waits for new PDF files, and when it finds one, it runs PDF to text with the -fixed option. This option tries to preserve the page layout by inserting spaces. The extracted text is then passed to a bunch of other shell scripts, which then control the GPIO pins. In hindsight, I should have used a real programming language, but I started out with just a bunch of shell scripts and I never progressed from there. I even added support for printing underlined text by pressing the backspace and the underscore key after every letter. Because we preserved the page layout when extracting the text, we can even print indented and aligned text, or tables. Or so we could. You see, there's one problem with this machine, and that is that it's just not reliable enough. Particularly when repeatedly pressing the space key, it tends to miss a key press every now and then. If you want to align text this way, then this is a problem. I tried all possible timing variations, and I even experimented with pressing the space key with 2 solenoids, but nothing seemed to fully solve this problem. I finally reached the conclusion that this is a problem with the typewriter. It's just not meant for typing many spaces in sequence without error. So I kind of gave up on it, and that's also why I haven't shared this project up until now. You see, I completed the typewriter about 3 years ago, back in 2022. I actually even had plans to print graphics on it. For that, I digitized the typeface of the typewriter. Because we can use the backspace key, we can print multiple letters on top of each other, like we did with the underlined text. So I wrote a program that used this trick to convert an image to a sequence of overtyped letters. Unfortunately, I never succeeded with printing a picture like this, due to the reliability issue. A lot of key presses are required for one picture, and there's zero margin for error. There's one more thing that we can do with this, and that is connecting it to my other typewriter. So behold, the copy typewriter. I guess in the 1960s this could have been a real product, but then again, there were no Raspberry Pis around then to build one. So that's it for now. If I keep this pace with making videos, I'll have another one out in 2032. I'll see you then. Bye.